In previous videos, we have created geometry for this case in Design Molder. And also we made the geometry as a parametric function of some variables. And now in this video series, we are going to make the hexagon meshing on this geometry. But before that, I want to discuss the different methods that can be applied on this geometry, for example. So first of all, I want to give you some idea about the very simple type of the meshing where we don't want any decomposition geometry here. So if I start from here, that is the extrude 4 or extrude 5, and from this onwards, these all options, they are done to create the decomposition of geometry for hexagon meshing. And let's say I just make these parts suppressed from the geometry. So just suppress them, and now you can see that we have this simple geometry without any decomposition. And if I open the meshing software here, the ANSYS Meshing here, and I will wait for this meshing to start, and then I discuss about different methods we can apply in this simple geometry. And the point is that I want to discuss is that the one thing is that you can apply any method of your choice. With the tetra method will be the simplest one and quickest one, and you don't require any geometry decomposition for this case. And secondly, I want to discuss about different methods of meshing you can apply in ANSYS Meshing. Now for example, right now there is no method, and the physics preference is CFD is very important, and the solver preference is a fluent because we are solving inside the fluent. But you should make sure these two things, that the physics preference should be CFD, not mechanical. And otherwise, if this is mechanical, then there are many options of meshing which are fine-tuned, are designed, are included for the CFD purpose. They will not be there. They will be not used for that mechanical option. So maybe you are trying to apply a sweep option and this option is not working, and the error is basically from there. And now just a quick mesh. So just click on update or generate mesh, and now just see that what it is going to do. Now you can see this is making some mesh here, and right now if I set the sizing of different things here, the gross Z, maximum size, so these all things are there. The D feature size, which is the minimum size we can have on the meshing, and then we can see the quality. And the important quality we want to see is the orthogonal quality, and its value should be more than 0.01 for the fluent. And you can see that the minimum quality is 0.196, and I told you that minimum quality for the fluent is 0.01. So we are well above that minimum cap on the mesh quality for the fluent. Second thing we can see is the skewness, and its value should be less than 0.93 for the volume mesh, and right now maximum value is a 0.8. And in the mesh statistics, we can see the mesh number of nodes, number of elements, and typically speaking, the number of nodes for pure tetra mesh and elements, they have some ratio something like 3 to 5 times. So nodes, if the nodes are 15, and if you multiply by the 4, so this will be 60,000, and somehow it's the 4.5 times the ratio of that value. And when you solve with the help of tetra mesh or the unstructured mesh, we always look for the number of cells. Not unlike the hexagon meshing, where we see that the number of nodes and number of elements or number of cells, they are same. And basically for the finite volume method, which is the background in the solver in the fluent, that uses the finite volume method, and for finite volume method we use a cell. So the cell is important thing, so cell number of cells should be up to some limit. So anyhow, I just wanted to show you that how you can see these things in the ANSYS Meshing. And what I want to use is that I want to discuss about this inflation method. And by default, the number of maximum layers are 5. Growth ratio is the 1.2. And the inflation algorithm is the peri. Peri means that it will create before the volume mesh. And post means that this will create the prism mesh after the tetrahedron are created in the volume, and then it will displace or cut them from the volume on the boundaries, and then it will create these inflation or the prism elements. And now the first important command is the meshing method. And so right click on the mesh and click on the insert and method. And you select the geometry, so you can right click here and select all. If you want to select all these geometry parts and you want to apply some particular meshing method or on the all geometries, or you want to apply the particular method on the one geometry, for example here, and other method on the second case and third case. So in that case you can use the different meshing methods. But right now you can see this is a single body here, and if I use the option as frozen, that is an extrude. If I use add, instead of add material, if I use add frozen, and similarly for this sweep method, use add frozen and click on generate. So now you can see now we have 3 bodies, and to connect them internally from meshing point of view, we have to create a single part. So they are three separate bodies, but to make connection between the meshing between all these bodies, we have to form a new part. So right click and form new part, and then after that I'm going to double click on the mesh, and this will open the, although this already is open, so it will open that workbench meshing software with a new geometry definition. And now we have 3 solids here, and they are in a single part. So it's very important they should be in a single part. Now let's say we define this first part, and we use the material option here, right? And click on update. And I just wait for the meshing to be done on this case here. And you can see that on some geometry we have the hexa meshing, on some geometry we have tetra mesh, and it's done automatically. And if I put the sizing can be defined for the body, which is the body here, can be defined for a single face, like for example this face or this face, and can be defined also for edge. And we not go for the point because this is no importance of the point in CFD. So we can define mesh on the edges, we can define mesh on faces, we can define mesh on the whole volume or body. And let's say we define some sizes. Right now I'm not going to define any size here. And so I will be putting the another method here. So I put this method as let's say it's a tetrahedron page confirming. And third method I would put for the another body, which is here, and I put the method as sweep method, and I want to try to mesh them with these all methods and want to see that what will happen here. So we have some error, and I want to see why this error is coming. So this is just exercise. And now I want to see the error messages, which are 3 messages written here. So mesh failed to initialize. So what I can do is that I can right click on the middle part and generate mesh on selected bodies. So maybe I can start from here, and this has been created, right? And second thing I want to put is the inflation. Inflation means that we can put the prism layers normal to the boundary of this geometry, and I would be putting these default options here in this face. And now I create the mesh, right? And also for this case, I'm going to create a face meshing, and I would call this face meshing as a map mesh, so that I can create like a hexa meshing here. And now click on generate. And so maybe we can select these two bodies from here and use the generate mesh on selected bodies. Still not, then maybe we can try another method. So instead of sweep method, we can try with multi-zone method here also, and click on update. And the purpose of this thing was only give you idea that how different things can be applied and how they will work here. So you can see that we have the hexa meshing here, which you can see very easily. And let's say I want to see the mesh from inside. And for that, I would be going to from the home, and we have section planes. From section planes, I can create a section plane, and that plane can be drawn on some rough axis. And then I can take a look on the mesh from inside. And you can see that how these elements are combining at the common edges. Okay, so in this way you can see the mesh, how this mesh will look like here. And now I would be putting the inflation layer also on this body. And so this body. So this is our method. I'm going to put the inflation layer. Right click here and use inflation. And this body and this surface, there are two surfaces I'm going to select. One is this one, and second one is over here. And apply and click on generate. And still you can see that we have the similar thing here. And from section view, you can check the mesh here also. Right, so this is all about the different methods we can use. And the best method I'm going to say is that we can use a single method and in the inflation layer. So for this very simple type of the geometry structure, for example, I can use this page confirm method and select all three bodies and apply on this one. And then right click here, put the inflation, all three bodies, and the faces I'm going to select are these faces 1, 2, 3, and 4 and 5. Apply and click on generate. And just wait for the mesh to complete, and then click on the mesh. And now you can see that we have the very nice type of the inflation layer, plus we have the tetra mesh here. And you can see that we have the stair up case type of here. So there's no prism layer on these two elements. And I want to show you one more thing is if I remove this option from here on the top side and generate the mesh with inflation option turned on, and then see what happens here. And you can see here. And then I want to show you one more thing. is that if I make the geometry as a single part, that is right now it's a single part, but there are three bodies. But if I make the body from a single body, and for that I have to make it add material, and also in the sweep as add material, and click on generate. And now it's a single body, and I can go back to workbench. From here, open the mesh, so now we have single body here, and the faces I'm going to select are 1, 2, 3, 4 and 5. Apply and click on generate. And now you can see that the prism layers, they are continuous. And if I go to section view, and from here, if I click on the show whole elements, and we can see them in a just like a projection of mesh on some plane. So you can see we have the 5 layers, and they are continually they are moving from one part to second part. But once we have these 3 bodies and single part, we can see they are discontinued in the mesh of prism at the intersection of these bodies. So you can see now this is what is happening. And now I can put the method, and let's say I put the method as the patch confirming, that is over here. Or maybe I can try with multi-zone mesh and click on generate. And I recommend that you should be trying these all things inside the ANSYS workbench and see how they behave. And you can see now we are able to create full hexa meshing, almost full hexa meshing without much effort. And if I can try to put the face meshing here on this face as a map mesh, yes. And then I can try that what will happen here. And if I take a look on the section plane 3 and click on the whole elements, and we can see that we have these prism elements, and in between them, inside in the interior of the geometry, we can see that we have the hexa elements which are going inside the geometry here. So we can also create the multi-zone mesh with these all hexa elements, and also we have the control over the boundary as well. So this all can be done inside the workbench ANSYS meshing with a few clicks.